Okay, students, today we'll do a new topic, formula of a compound and number of voids filled. When we have done closed packed structure, then we have got two types of voids. Some voids are called tetrahedral voids and some voids are called octahedral void. Now, what is the importance of this void? Actually, void means nothing. These are gap in between the particles. Since there are two types of void, octahedral and tetrahedral void, in case of ionic solid, for example, if you consider sodium chloride, you know sodium is cation, chlorine is anion. The ion which is larger in size, normally anions are larger. Since the size of chloride is greater than the sodium ion, that is why this chloride ion adopt the arrangement of the solid. It will adopt the arrangement, and this sodium ion will present in void. And this is the importance of void. Actually, void also contains some particles. If the cation is smaller, then the cation will occupy the void, and if the anions are smaller, then anion will occupy the void. Now, as you know, there are two types of void, tetrahedral voids and octahedral voids. So the ions may be present in tetrahedral void, may be present in octahedral void, depending on the formula of the compound. And you have got, if the arrangement, if the total number of particles in the arrangement, if it contains n number of particles, then the number of octahedral void will be n and number of tetrahedral void will be twice n. If your arrangement contains 100 particles, then inside that arrangement, inside that 100 particles, you will get 100 octahedral void and you will get 200 tetrahedral void. So this is the calculation how to find out the number of tetrahedral and octahedral void. So how many particles you have arranged, based on that you can find out the number of tetrahedral void and octahedral void in your arrangement. If you arrange 1000 marbles, if you arrange 1000 particles, then number of octahedral void will be 1000, number of tetrahedral void will be 2000, double of the arrangement particles. For example, suppose there is a solid whose formula is AB. Suppose the formula is AB, and here we consider A is cation, B is anion. So if you want to find out who will adopt the arrangement, who will adopt the void, and which void it will adopt, whether it will adopt octahedral void or tetrahedral void. So to find out that, since normally anions are larger, so B minus ion should be in the arrangement. If you arrange the particles like this way, then these particles are nothing, these particles are B minus ion. These are all are B minus ion, and you know these are the voids, na? Since A plus ion is smaller in size, so it will occupy the void. Now, in which void, whether it will occupy tetrahedral void or octahedral void, here the ratio of A and B is 1:1. Since it is 1:1, if the number of particles of B is n, then number of A particles should be n. It should be n:n, then you will get 1:1. And n:n ratio you will get when the particles are present in octahedral void. And that is why in this type of solid like AB formula, if the anion adopt the arrangement, the A plus ion, the cation, must be present in octahedral void, so that you will get the ratio 1:1. So based on the formula, you can find out the ion will occupy what type of void. It will occupy tetrahedral void or it will occupy octahedral void. And suppose A plus ion is not present in octahedral void, there is another possibility for A plus ion. As you know, number of tetrahedral void is twice n. The ratio n:2 twice n means 1:2. There is another possibility for A plus ion. A plus ion may be present in half of the tetrahedral void, because the ratio is 1:1. Since the ratio is 1:1, here arrangement contain n, tetrahedral void contain twice n. n:2 twice n means you will get 1:2 ratio. So if the particle are present half of the tetrahedral void, then the ratio becomes n:n. So that is why there are two possibilities for this cation. A plus ion may be present in octahedral void, or A plus ion may be present in half of tetrahedral void. So there are two possibilities for this type of formula. If the formula is AB, then the anion will adopt the arrangement and A plus ion will be present in the void. Now what type of void? The A plus ion may be present in all octahedral void, or A plus ion may occupy half of the tetrahedral void. This type of arrangement you will get for this type of formula AB. Now suppose the formula is A to B. Suppose the formula is like this, A to B. Here the ratio of A and B is 2:1. Since the ratio is 2:1, if the number of particles of B is n, A must be twice n, then you will get the ratio 2:1. So here, if B minus ion adopt the arrangement, I mean if the number of B minus ion is n, then the A plus ion must be present in tetrahedral void, because if the arrangement contain n number of particles, number of tetrahedral void will be twice n. Ultimately you will get the ratio 1:2. I mean you will get 2:1. So you will get the formula A to B. A plus ion is 2, B minus ion is 1. Ratio is 2:1. So if the formula is A to B, then B minus ion will adopt the arrangement and A plus ion must be present in your tetrahedral void. So this is another one. Now suppose the formula is AB2. This is another formula. For example, you can consider calcium fluoride, this type of formula, AB2. If the formula of the solid is like this, then the cation must be present in arrangement. It will be present in arrangement. I mean it will adopt the arrangement, and B plus ion must be present in tetrahedral void, because the ratio is 1:2. If it is n, it is twice n. I mean ratio 1:2 you will get. So that is why based on the formula, in the formula what is the ratio of your cation and anion, based on that you can find out who will adopt the arrangement and who will be present in void, and in which void it will be present, whether it will present in tetrahedral void or octahedral void, you can find out from the ratio of the cation and anion. So for example, if you consider sodium chloride, here the ratio is 1:1, so it will adopt the structure like AB. I mean the formula is like AB. If the formula is like this one, Na2O, its formula is like A to B. A to B. So it will adopt this type of arrangement. If the formula is CaF2, then it will adopt AB2 type arrangement. I mean calcium will be present, calcium ion should be present in the arrangement. I mean it will adopt the arrangement, and the fluoride ion must be present in tetrahedral void. So this is the way how to find out the structure of solid. So if you know the formula of the solid, then you can find out the position of your cations and anions present in the solid. Now I'll give you some structure of solid. In case of sodium chloride, Cl minus adopt CCP arrangement. These are experimentally obtained. CCP arrangement, and Na plus ion occupy the octahedral void. This is the structure of sodium chloride. These are experimentally observed. Cl minus ion is larger in size, that's why it will adopt the arrangement, and CCP arrangement, I mean like FCC, and the sodium ion will occupy all the octahedral void because the ratio is 1:1. This is one formula, ZnS, zinc sulfide. This is also one example of ionic solid. So here sulfide ion S2 minus adopt the CCP arrangement, I mean FCC arrangement, and this Zn2 plus ion occupy half of tetrahedral void. half of tetrahedral void. Then the ratio also become 1:1. So this is the structure of zinc sulfide. If you consider calcium fluoride structure CF2, calcium ion adopt CCP arrangement, I mean FCC, CCP arrangement, and fluoride ion occupy all tetrahedral void. That's why the ratio is 1:2. If you consider sodium oxide structure, then you will get CCP arrangement of oxide ion O2 minus ion, and sodium ion is present in tetrahedral void because the ratio is 2:1. That's why it must be present in tetrahedral void. So these are different structure of different solid which are experimentally observed. And one structure you have to know, cesium chloride. Here simple cubic arrangement, I mean the particles are present only at the corners. Simple cubic arrangement of Cl minus ion and cesium ion at the body center. This is the structure of body center, means it is present at the center of the cube. These are the different structure observed experimentally for different types of solid. In sodium chloride, the coordination number of Na plus ion equals 6, Cl minus is also 6. I mean each sodium ion is touching by 6 chloride ion. Similarly, each chloride ion touching by 6 sodium ion. These are the coordination number. Similarly, for ZnS, coordination number of zinc ion is 4, sulfide ion is also 4. Here one zinc ion is touching by 4 sulfide ion, like that. In case of cesium chloride, cesium ion 8, chloride ion also 8. I mean each sodium ion is touching by 6 chloride ions. Similarly, each chloride ion touching by 8 cesium ions, like that. In case of calcium fluoride, calcium ion is 8, fluoride ion is 4, coordination number. And in case of sodium oxide, sodium ion 4, oxide ion 8. So these are the possible coordination, not possible, these are exact coordination number which obtained experimentally. So you should know about the coordination number of different ions present in different solid. According to syllabus, only these 5 solids are required. That's why you should know about these 5 solids.